Okay. Hello, everyone. Welcome. So today we're just going to have a quick little tutorial about how to analyze your data, how to make a graph for your data, because you're going to need that for your Blackworm lab report. So let's dive in. This data set isn't fully complete, unfortunately. It looks like some people forgot to enter some of their data. So we'll just do a quick example using just two of your data points. The first being the control, which is arguably the most important part here. And then we'll use St. John's wort. So what I've done here is I just typed in average and standard deviation, and then I've typed in control in St. John's wort. And so what we're going to do is just do some quick Excel math. So we're going to hit equal sign. That's how you always start math in Excel. Average. Now you'll recall from probably a long time ago is the average essentially is getting at what's the most common number that you're getting at, right? What is the most common observation? Now, in our case, it's what's the most common observation mathematically defined as our heartbeat, right? So I did equals average and I selected all the cells for my control. And I'll do the same thing for my friend, St. John's wort, again, selecting all those cells. So that's the first part. Got to take the average. Now, the next part is where we're taking the standard deviation. Now, in Excel, to do this, we do STDEV. You don't need to do, you'll notice it says PS and A and PA. Don't worry about any of them. Just do STDEV. Don't worry yourself about what that means. Now, what the standard deviation is telling you here, and you'll see I did it for control, and I'll do it again for our friend St. John's wort. But what this standard deviation is telling you is how much variability is in your data. Now, to give you an example of what that means, we can pretend we have two hypothetical samples, A and B, or categories. Now, we could pretend that I have a heartbeat of 10, a heartbeat of 10, and a heartbeat of 10. And for B, I could pretend I had a heartbeat of 5, heartbeat of 10, and a heartbeat of 20. Now, when we calculate the standard deviation of these things, as you'll notice, the standard deviation of group A is 0. The standard deviation of group B is actually 7.63. Now, what that's telling us is that group B or sample B, whatever you want to call it, has more variability in the data, right? And you can see that, right? The variability ranges from 5 to 20 beats per minute. Now, conversely, we can see that for group A, the variability is 0 because there's only a measurement of 10 beats per minute, right? So that's what standard deviation gets at, is how variable is your data. That's an important component of data analysis, is how variable is your data. So that's what standard deviation is. Now, when we look at what we have here, you'll see that the control has a standard deviation of 7 beats per minute, of course. And the St. John's wort has a standard deviation of 11.5 beats per minute. So what we can actually say is that while the average of St. John's wort is higher, there is more variability in the data in St. John's wort relative to control. And you can just physically see that, right? St. John's wort goes as high as 48 and as low as 17, but your control goes as low as 16, but only as high as 35, right? So significantly less variability. So that's part one. We've got to calculate the average and standard deviations. You want to do that for all of your samples. I recommend setting it up in a table, very much like I have here. So for instance, you would put caffeine here and so on and so forth. So next, we want to make a little bar chart. And this is very similar to making the chart that we did for our amylase experiment. We want to select our data as such. So we do want it set up like this, where we have a column for it says control, St. John's wort, and so on and so forth. We want to select the average here. And what we're going to do here is go up to insert, and then we're going to go to here, where it says column chart or bar chart. If you want to do one of the weird 3D column charts, go for it. I prefer just the 2D ones. I think that's just me being old man. Now, this graph we're making, you can make this style of graph in Google Sheets and the online version of Excel. But unfortunately, to do the error bars the way we're going to need to do it, you need actual physical hard copy of Excel on your computer. And so if that's a problem for anyone, please reach out to me and I can certainly help you. However, we do need, again, that hard copy, unfortunately. So it has to be like on your PC or on your Mac. If you have a Chromebook or you work with the tablet, again, just let me know. So what we first want to do here is actually, let's just move this bad boy over so we can see. What we want to do is actually go to add chart elements. So we can do that in one of two ways, up here in the upper left-hand corner, or this little plus sign here. I prefer the upper left-hand corner one. I don't know why. But first thing we want to do is add first a primary. First we want to do is add a primary vertical axis here. So our primary vertical axis, we want to label it. So we want to put heart rate because that's what it is, right? But as we've discussed, units are very, very important because units tell you how much of a quantity you have, right? If you write, for instance, 325, pretend you're a doctor and you write, oh, I want to give this person 325 aspirin. Well, does that mean you want to give them 325 milligrams, 325 tablets, 325 grams, right? You don't know, but units are really important. It will save potentially your butt, right? And that's what we want. We want to make sure we have our axes labeled for our horizontal axis or the y-axis. I don't care about chart titles. If you want to put a chart title, make sure it doesn't just say chart title. Make sure it says something informative. But I don't really see the point of chart titles, so I don't use them. So you don't need an x-axis title here because we know, right? Each bar is this bar is control. This one is St. John's wort as it's labeled. You want to make sure that it just says control in St. John's wort and nothing else, just so it's as least confusing as physically possible. Now what we want to do is add some error bars, but the error we want to add is actually the standard deviation. So what we want to do is either click this plus sign and we would go to error bars here and then click that little black line, or we simply go up to the upper left-hand corner here where I am, error bars, more error bar options. And so what this is going to do is going to bring up a little side menu. Now, you can fiddle around with all these things. So for instance, like if I were making this, I only like to do plus error bars, but it really doesn't matter. You can do whatever you want in terms of fiddling around with how the graph looks. But the key here is we go down to custom and we click specify value and it'll bring up this little thing. Now, what we want to do here is actually physically just select the cells. So as you can see, I just clicked on that cell and I selected both of them. And we want to do that for the positive error. And we also want to do that for the negative error. Again, selecting our standard deviation. We click OK, and then bam. You notice that we now have error bars and they correspond to the standard deviations of each sample, which is nice. If you have any other standard deviation, for instance, if we go to add chart element again, and we go to error bars, error bar options, if you do fixed value percentage or standard deviation, those will be wrong. Right? You need to select custom and select your calculated standard deviations. And in terms of your graph, that's what you get, right? So you have the mean or the average, right? You can see that the average is lower for the control than it is for St. John's wort, but you notice that the standard deviation, which is simply the size of those error bars, is different between them, right? The control error bars are smaller, St. John's wort is larger. So that's how we make our graph. And so you're going to want to make sure you know how to do that on your own. Now, the next thing is we want to actually say, okay, are these two categories, does St. John's wort mathematically increase the heart rate relative to the control? So what we want to do is apply what's called a t-test. Now, a t-test is a mathematical test to allow us to confidently say if two groups differ from one another. And again, we can apply math to it. As we discussed in lecture, without math, science is really nothing. So what we need to do is we want to actually set up a little column. So what we want to do is actually have so St. John's where I can learn how to type alcohol, chamomile, and then so on and so forth. And we want to actually write what's called here the p-value. So you're actually going to want to create a table for your lab report where we compare with the t-test all of these categories, these 5 categories, to the control, because that's the idea, right? The control serves as essentially what happens in the absence of our treatment, which is these plant-derived compounds, and that's the comparison we want to make with the t-test. So it's actually very, very simple. What we need to do is hit the equal sign. We'll do t.test. We'll hit open parentheses. We'll select the control. So you'll notice I'm just selecting the control here. We hit a comma. And so I'm going to select St. John's wort after the comma. And now what we want to do here is actually do 1, comma, 1. So that's the way we want to do it. There's a long mathematical example reason as to why we do that, but we'll just ignore those parts for the sake of this tutorial. And we get a p-value of 0.06. And for instance, if we do caffeine and alcohol, we'll just have another comparison here. Again, t.test, we select the control. We select caffeine and alcohol. Then we do 1, 1, and we get a p-value of 0.38. Now, what does a p-value really tell us? Well, it's the probability that we have a false positive, in the sense that if we have a high probability, so for instance, we have 0.38 or 38%. In this case, we have 0.06, which is 6%. So what it's telling us is what is the probability that we have a false positive? Now, a false positive would essentially be like where we say we have the right answer, but we actually don't. In the sense of, like, if you went to the doctors and you took a blood test for cholesterol, for instance, and the blood test came back and said that you have high cholesterol. But in reality, if you ran that test a couple more times, it told you you didn't have high cholesterol. That very first measurement that said you had high cholesterol, in spite not having high cholesterol, actually is a false positive. And so what this tells us, the p-value tells us, is what is the probability that we have a false positive, that there is no mathematical difference between our two groups. So the critical value here is less than 0.05 or 5%. If p is less than 0.05, we're pretty confident we don't have a false positive, that there is an actual mathematical difference between the comparison. So in this case, I have a p-value of 0.06. It's greater than 0.05. Thus, I am not confident that there is a mathematical difference between the control and the St. John's wort. Thus, I can conclude that there is no effect of St. John's wort on the heart rate of our worms. So again, it's a mathematical way of saying, is there an effect of a treatment? But we can also tie this back to our hypothesis. So if you hypothesize that St. John's wort would increase heart rate, well, if your p-value is greater than 0.05, you actually have to reject your hypothesis, right? Because again, you're not certain that you don't have a false positive here. So that's the way we interpret these p-values. What you want to do is a t-test comparing all of your categories to the control. That's all you want to do. You don't want to compare them to each other. You just want to simply compare them to control. That is it. So that's the end of our little tutorial. Please reach out to me if you have any questions, but I hope that was helpful, and I will see you guys in class. Take care.